welcome to this new video tutorial about Fantasia. And in this video, I will be showing you how you can integrate Fantasia with the AI system of Unreal, specifically with Behaviour Trees. So first of all, we'll need a blackboard. A blackboard will contain a set of keys that will help us keep track of the context in which the dialogue is happening. So we will keep a reference to the Bayesian network that we're using, to the last variable that we inspected, the last user utterance, if it is the time to take the turn for the system, what the system last said, the user name, so that we can also see how to ask for the user name, the user the system is interacting with, the system name, the last action performed by the system, and the last user intent. These are two enumerative types. We won't be using these a lot, but they just list what the system and the user can do. Next, we need an AI controller for JSON. This AI controller will make use of a behavior tree. So it will run a behavior tree that we call JSON tree. We will see this in a few moments. And it sets up default values, starting values for all the keys in the blackboard that we just saw. Next, in the blueprint representing JSON, controlling JSON, we have to make sure that our JSON is a POM so that we can assign the JSON AI controller to the AI controller class here. Once we did this, we can get a reference to the blackboard used by AI controller here. And we can move the logic that was here inside a behavior tree. So most of the old blueprint is gone, as you see. Here we only have a logic here linked to the transcriber, the Azure transcriber providing a response that will update the last user utterance key in the blackboard with the message coming from Azure ASR. And in the case that the last system action was to ask the name of the person, then it will also update the username key in the blackboard, because this should be the answer to a question asking for the name of the user. Then it sets the take turn Boolean variable to true to indicate that it is time for the system to take the turn, and it will revert the ice color back to normal. Here for the speak event, it just calls the TTS start event. All the logic generating sentences is not here anymore, so we just need to call the TTS when the speak event is called from the behavior tree this time. So let's go inside the behavior tree using this blackboard, and let's see how it is organized. First of all, we have a selector, and this selector will try at first to run this subtree, which describes the logic with that makes JSON ask for the name of a person and keep track of this move, this dialog move. This is a sequence of two tasks, asking for a name and updating the DST, the dialog state tracker, which is implemented in Neo4j. We will see it in a moment, with the sentence that the system asks. This is only run if this decorator here is true. So if we don't know the username. So username is equal to the empty string, and if it is, our turn. The task to ask the name of the person consists of this blueprint. So that we call the speak event on the blueprint representing JSON with the sentence, hello, what's your name? We also update the key of the last system utterance with the same sentence. We update the last system action so that we represent the fact that JSON asked for the name of the user. And we put the take turn boolean to false because we took the decision about what to say and it's not our turn anymore. The task finishes with a success in this case. If the task succeeds, then this other task is run, and this task is designed to take a cipher query as an input, the utterance that was just said, and who said it. So let's jump inside this task. And again, we can get the controlled poll meta.json, which is equipped with the Neo4j component, if you remember from the basic tutorials. We can use this component here to send a query to Neo4j, the query that we get as an input. As you can see here, the query variable is public. And we use the two keys that are incoming from the blackboard as the parameters of the query. Now, as soon as Neo4j responses, we can indicate that the task succeeded. So this query is designed to add a node in the graph and link it to the last utterance that was just said. So in this example, we will be tracking the dialogue in the sense that we will make a chain of utterances appear in Neo4j so that we can see at the end of the test who said what and what was the sequence of the sentences that were uttered. So if this succeeds, because both nodes succeeded, then the tree is run again. It is not our turn, so this is not executed, this is not executed, and the tree will enter an infinite loop. To get out of this infinite loop, we set up an observer on this decorator. The observer here will abort lower priority trees if the result of the condition changes. So if the take turn value in the blackboard becomes true. And this is only true when a transcription arrives from Azure, blackboard values are updated, and the Boolean values for take turn is set to true, as we saw before. So this is aborted. Since after asking the name of the user, here the name of the user is recorded, this subtree cannot run anymore, and this one will attempt to run. So first of all, the same DST update task will be executed, but this time we will add a user node so that we have system nodes and user nodes describing who said what. Next, since we got an answer from the person we're interacting with, we will run this update Bayesian network task, which is part of the logic that we already saw in the last video, the one managing yes or no questions, yes or no answers from the user, if they're present. so that we can make inference about what happened during the task. Next, we will try to select the most appropriate dialog move, exactly as we did in the previous video. So this selector will try to take a stance about the grass being wet, if you remember the example from the last video, but only if the threshold on the entropy here is lower than the given one. So if the entropy value is lower than the threshold I give here. So this is another blueprint. And again, it's another piece of the logic that we had in the previous video in a single blueprint. So it's just checking if the entropy of the W value is higher or lower than the given threshold, and it will return true or false accordingly. So if the entropy threshold of the target value is lower, is the entropy value of the target variable is lower than the threshold, then JSON can take a stance and about the most probable value for W. Otherwise, the selector will try to check if there is an entropic variable, which is the most entropic variable in the system, and it will ask a question here, as you can see. Again, part of the old logic moved here, depending on the maximum value of the entropy. So in here we have again the same logic from before, looking for the maximum entropy value. This time it will return true if it found a variable that has entropy higher than 0. Otherwise, it will return false. This means that there are no variables with entropy higher than 0. If this returns true, the task is executed, and the question corresponding to the variable that must be investigated is generated, just as we did in the previous video. So as you can see, this blueprint here calls the speak event with the appropriate sentence given the variable that should be investigated as indicated in the blackboard key. Everything is practically identical to the last video, but this time we are distributing the logic inside the nodes of the behavior tree. Again, not our time to take the turn and return a success. If this fails, then regardless of the entropy value of the target variable being lower than the threshold, JSON needs to take a stance. So we have the same task here, take stance, that takes priority over everything if this condition is verified, but is executed anyway if we don't have any questions to ask. This subtree always returns true, always finds a way to execute one task. So this sequence node will then execute again the DST update task, adding the last question or the system taking a stance to the chain of links that we will be building inside Neo4j. So as you can see, the strategy here is to move the blueprint logic that we had inside the JSON blueprint in the task nodes and in the decorator blueprints associated with the nodes, so that it is clearer to follow what the actual reasoning of the agent is doing. And it is also easier to update because everything is modular, We can always add new subtrees and simply handle their priority using positioning as usual in Unreal. In general, it is much cleaner. Everything is reusable. For example, you can see here parameterized tasks using keys and strings for queries so that we can parameterize queries in Neo4j too. So we're combining the advantages of Fantasia with the power of behavior trees inside Unreal. So everything should be identical to the last video, with the difference that this time JSON will first of all ask for my name, then it will move to exploring the Bayesian network for the sprinkler problem, for the wet grass problem, identical to what it was doing before. Plus, it will be tracking the dialog in Neo4j using these nodes here designed to take advantage of the Neo4j component associated with the JSON here. So let's run this and let's see what happens. I will keep the tree running here so that you can check what's happening. And I will only keep the JSON eyes visible, or maybe not. Let's do it like this here, that we can see everything. Let's run this.
Hello. What's your name?
Antonio.
Is it raining?
Yes.
Is the sprinkler on?
Yes.
The grass will be wet.
So as you saw, the tree here was running. And every time I gave an answer, then it was re-evaluated and it was stopping in the loop to wait for my answer. And depending on my answers, different things happened. So taking a stance, asking questions, asking for my name before everything, etc. Just as we designed. Now let's move inside Neo4j and let's check what happens on the DST side. Here we will have a series of nodes representing users and the system, an uttered relationship representing utterances. We can get all these nodes to check what happens during this what happened during this conversation. So let's run this, and as you can see, here's JSON and there's me. So as you can see, it's using the value assigned to the username blackboard key to set up the property, the name property of the user node inside Neo4j. And we have the dialog represented as a chain of utterances here. And we know who said what, and we can follow the chain of followed by relationships to reconstruct the dialog. So this is how you combine AI in Unreal to handle Neo4j and to use Bayesian networks to take decisions about what to say. In the next videos, I will show you how to improve the connection between this system and Neo4j to also keep track of the information coming from natural language understanding.